Welcome. Do you want to see how the laws of thermodynamics and kinetic energy can make water boil using friction? Try an experiment with me. Rub your hands vigorously together for about 5 to 10 seconds. And while you're doing that, can you feel the heat being created? So what we're going to do today's experiment, we're going to use a Vitamix blender. As you see here, we're going to put 5 cups of water in here, and we're going to experiment to see if friction will indeed boil this water. So join me in the next few minutes and I'll show you this experiment and we'll see. Will the water really boil? Come on down, let's go to it. So in the comments, if you guys can let me know, will this water boil? And also take a guess. How long do you think it would take to boil? If it does. And to show there's no trick photography involved, we're going to have everything running on a timer. So you're going to see in real time how long it takes for the reactions to happen. And once in a while, what we're going to do is we're going to stop the clock along with stopping the Vitamix, and we're going to take temperature readings so that you can also see how fast the water is heating up and to see what our progress is. So let's get going, you guys. First step is going to be 5 cups of water. There we go. 5 cups of water. So, now let's cap this. Make sure it's nice and tight. We don't want water splashing everywhere. And I'll be holding this down so it doesn't bounce. Nice thing about the Vitamix blender is you don't have to start full speed right away. You can start off slow and then slowly crank up the speed. So it is time to get ready to go. You guys ready? Let's have some fun. Let's see if this thing's gonna boil. Ready, set, go. Whoops. Okay, stopped it at 2 minutes and 1 second. So let's just see what's happening here. Come up close, we can check the temperature of what's happening inside. See, the water is already at, I'm basically shining it, if you can see, right on the center of the blades. Right in the middle container, 37 degrees, 37.1 degrees Celsius. Okay, so in Fahrenheit, that's probably 95 to 97 approximately. Okay, let's turn it back to 0 and let's get it started again. So 2 more minutes have gone by. Let's see what we're at, how much the water has increased in temperature. And right at the same point again, we are at 52 degrees, 52.2 approximately, 51.5. So, okay, and just to keep in mind, water boils at sea level at 100 degrees Celsius. In Fahrenheit, for all my friends outside of Canada, it's 212 degrees Fahrenheit that the water boils at. So we're more than halfway there, you guys. So let's fire this thing up again. Let's go for another 2 minutes. Okay, I can feel quite a decent difference in the temperature in those last 2 minutes that we just did. So let's see where our temperature is at now. Oh, you can see a lot of steam here already. Around that 62 degrees Celsius mark. Okay, so the temperature is getting up there pretty nice. Let's seal it up good. Make sure we're good. And let's do it another 2 minutes. Ready, set, go. See how much steam comes this time. Oh yeah, a lot more steam. Okay. Around that 72 and a half degrees Celsius mark. So as you can see, the temperature is rising quite consistently. And you can feel on the side, probably by the end of the next 2 minutes, won't be able to touch the sides, it'll be so hot. Okay, ready? Here we go again. Okay, so it is getting really hot on the outside of the container. So this water is consistently going up in temperature. So I have to be more cautious now when I remove the lid, which is made of rubber. So that insulates some of the heat. But yeah, even that lid is getting quite hot. So 82 degrees Celsius. So we're getting there. Another quick tip, boiling points can be affected by altitude. Boiling points of water can also be affected by minerals, if there's any chlorine, fluoride, any types of chemicals or anything added in the water treatment process. So that can also affect the water boiling point just a little bit. And by the looks of it, we're getting about 10 degrees Celsius every 2 minutes. So let's go for another 2 minutes, you guys. Turn it back to 0. Ready to go, guys? Let's go. Oh yeah, she's getting pretty hot. I have to be careful to let the steam go on the opposite side of where my hand is for safety. So we're basically looking at that 89, 88, 89 degrees Celsius mark. So we're gaining every 2 minutes approximately almost 10 degrees Celsius. So we'll cap this and we'll go for another 2 minutes. Turn it back to 0. Ready, guys? Let's go. Oh yeah, there's a lot of heat there. Okay, 92 degrees. So the process is slowing down a little bit as we're getting close to the boiling point. I think we're gonna run it for another couple minutes and see where we're at. Okay, 0, let's get ready, go. Okay, so I think we've basically proved the fact that given enough time for sure that this water will definitely boil using strictly friction alone. As the process slows down, it's just going to take more and more minutes to get to that final few degrees Celsius to come to a full rolling boil. And plus, for safety concerns, we got to be careful because of the amount of heat that's coming off of this container. You can see the amount of heat coming out of there. You can already start seeing from the bottom, you can see it starting to bubble. You can see bubbles in the bottom already slowly coming up. So let's check the temperature again. Yeah, showing 92. Actually, technically, we should have actually like a proper thermometer that you put inside of a turkey or put inside of water instead of one of these. But this gives you a really good idea of how hot this water is and that it'll boil. So, did you guys guess correctly? Would you believe that it was going to boil using friction, or that it would come close to boiling with friction? Did you guess more or less how many minutes it was going to take? Well, that was a fun experiment. So we're going to try another experiment right after this. We're going to be using a small little solar generator. So if you don't have full AC power and you only have a tiny little solar generator, you could also do the same experiment and you can heat up soups. You can make water for coffee or tea, or heat up some water for washing, and that using a lot less electricity. And I'll show you how little electricity you can get away with in order to try to heat up and boil water. Hi. So now we're going to do this full experiment where we're going to use a small EcoFlow solar generator in order to produce friction heat using the Vitamix blender. Now the Vitamix blender uses a tremendous amount of energy, similar to what a kettle would use almost, at high power when it was doing the other experiment. But let's say you have a tiny little solar generator, the ones that you can get for $350 to maybe $425 on sale, that you can carry around with you, that are maybe 10, 12 pounds. Well, those things usually put out about 500 watts in that general range of continuous energy, and some of them have 700 watts to 1,000 watts of surge power. So this experiment, we're going to want to show the capabilities that a small solar generator using around 500 watts can end up boiling water using the same Vitamix. We just have to turn the speed way down, equalize it at around 500 watts of consumption, and see how long it takes to boil some water. Okay, first part of the experiment, we've already put room temperature water in here. Let's take a temperature reading before the start of our experiment. So you can see the water temperature is around that 23.3-ish Celsius mark. Now, we are going to make sure that we run about 500 watts about output power. And we're going to time it. So we're going to do 3 things at once. Get it to 500 watts, time it, and regulate the speed of the blender in order to get that 500. Okay, turn it down to 0 and let's get going. Oops. Let's start my timer again. Ready? Go. So the reason I let it go for 3 minutes versus 2 minutes with the other experiment is because with a lot less speed, a lot less agitation and friction and kinetic energy, the water is going to heat up at a lot slower rate. So let's check and see what's happened in the last 3 minutes to the water temperature. So even with a lot slower speed, you can see it went up from that 23 degrees Celsius. We're now at around that 29.9 to just a hair over 30 degrees Celsius. And that's in 30 minutes at a lot slower speed and only using continuously around 500 watts of energy. So you can see through proof that a very, very small solar generator can indeed boil the water given enough time. But we're going to keep going. Let's do another 3 minutes and see where the water temperature is going to be. Okay, so another 3 minutes have gone by, and as you can see on the solar, this very small solar generator is down to 94%. So we've only used 6% power to get to this point, so more or less we're using about 1% a minute in order to heat up the water. So let's see what our temperature is after 6 minutes, you guys. So as you can see, we're basically running 36.1. So went up about 6 degrees in the last 3 minutes. So we're getting about 2 degrees Celsius per minute approximately. So at this rate, it's going to be a while. So in an interest of time, what I'm going to do for safety, because as the water starts boiling and getting hot, I don't want any water to accidentally splash in case of a catastrophic failure, so I'm going to move the EcoFlow unit far out to the side, along with the timer. And I'm going to turn it on and run it for a little while, and then we're going to come back and check on it. So we'll see you in a few minutes. So a few minutes have transpired since I've last showed you the temperature in here, and when I open it up, I can definitely just feel the heat coming off of it. It's definitely a lot warmer than it was a few minutes ago, but like the other experiment where we were 16 minutes into it and then only got to around 92 degrees Celsius. In order to get to that same 90-some degree Celsius mark, is it going to take an hour, 45 minutes, 2 hours? Will we be doing this for breakfast tomorrow? I don't know. But it will definitely heat up the water. It's just that there's less kinetic thermal energy going into this through friction. So it's going to take a lot longer because of the speed of the blades. So I appreciate everybody coming to see my experiments. Please like and subscribe. Do you have any comments? Is there any other experiments that you guys would like me to try? But until next time, thanks for coming. Peace, and I'll see you next time on Ranger Dave Homestead. Goodbye.